Hello everyone, welcome back to my channel. So in this video we are going to learn about linear and non-linear systems. Linear and non-linear systems. Okay, so a system, which system is said to be a linear system, or what are the properties of a system so that it is called as a linear system. So generally saying that a system is said to be linear if it obeys superposition principle. Okay, superposition principle. Right, any system which obeys superposition principle is said to be linear system, and any system which does not obey superposition principle is said to be non-linear system. Okay, so very simple. If it obeys superposition principle, it is linear system. If it does not obey, it means system. If it does not obey superposition principle, it is non-linear system. Okay, so what is superposition principle? Superposition principle again consists of two principles. One is principle of additivity, and second is principle of homogeneity. So if any system which obeys both the principles, that is principle of additivity and principle of homogeneity, is said to obey superposition principle, and any system which obeys superposition principle is in turn called as linear system. Okay, so that means we have to learn about these principles in detail, so that if these two principles are obeyed, then we can say that superposition principle is obeyed. If superposition principle is obeyed, then we can say that it is a linear system. Okay, now see, if there is a system like this whose input is x of t, okay, so this is a system and its output is y of t. Okay, input is x of t and output is y of t. For the same system, suppose input is x1 of t and output is y1 of t. Right, next there is the same system is there, which I have taken in this case. So this system is same as this system, but the input I am changing. So if input is x2 of t, then its corresponding output is y2 of t. Okay, assume that if the input is x2 of t, then its corresponding output is y2 of t. If input is x1 of t and the corresponding output is y1 of t. Okay, for the same system we are applying two inputs and correspondingly we are getting two outputs. Right, so what does this principle of additivity tells you is, for the same system, if you take the same system and individually if you give x1 of t and x2 of t, you will get the outputs y1 of t and y2 of t. So principle of additivity tells you that if you give the sum of the two inputs at the input side of the system, you should get the sum of the outputs at the output of the system. Okay, so this principle is called as principle of additivity. Okay, so individually if you give the inputs, you'll get the individual outputs, but if you add those inputs and give it as a single input to the system, then the output of the system will have a single output, and that should be the sum of the two outputs of y1 of t and y2 of t. Okay, so this principle is called principle of additivity. And now what is principle of homogeneity? So if you are giving x1 of t, you are getting y1 of t, and if you multiply the input by a constant, that is if you scale the input by a constant, that is a into x1 of t, you make the input scaled by a some constant a, then the output must also be scaled by the same factor. X1 of t output is y1 of t, then a into x1 of t output should be a into y1 of t. Okay, so combining these two properties, what can we say? That a system is said to be obeying superposition principle. Superposition principle, if it obeys the both properties. So combining these two, what can we say? For the same system, we are applying both principle of additivity and homogeneity. So a into x1 of t plus b into x2 of t is the input to a system, then it should produce a into y1 of t plus b into y2 of t. So if the input is multiplied by a, output should also be multiplied by a. If the input is multiplied by b, that is x2 of t is the input multiplied by b, correspondingly output y2 of t should be multiplied by b. So if the two inputs are given, then the output should also be the sum of the two outputs. Okay, so this principle is called as superposition principle. Okay, so this is called as linear system in detail. Okay, so the steps we require to solve the problem here. Okay, so for a given system, they will give you some systems and they will ask you to find whether the given system is linear or not. Okay, so in order to solve that, first of all, what we take is, we'll take a into x1 of t is the input to system, and we'll write the corresponding output a into y1 of t. b into x2 of t is the input we'll take, and we'll write the corresponding output b into y2 of t. Now in the third step, we'll give a into x1 of t plus b into x2 of t as the output, and we will check the output y3 of t. Okay, so if this is the input, then we will write the output as y3 of t, and what we have to check at the last is y3 of t should be equal to a into y1 of t plus b into y2 of t. If this happens, then we can say that it is a linear system. If this does not happen, that is y3 of t is not equal to a into y1 of t plus b into y2 of t, then that system is said to be non-linear system. Okay, so this is what we are going to do. So for the given system, first of all, we have to give the input a into x1 of t, and we are going to have the output a into y1 of t. b into x2 of t is the next input, b into y2 of t its corresponding output. Now we are giving the combination of these two and storing the output as y3 of t. This y3 of t should be the addition of these two. So if y3 of t is equal to a into y1 of t plus b into y2 of t, then it is a linear system. If it is not equal, it is a non-linear system. Okay, so next we will see some of the examples to find whether the given system is linear or not. So first example, y of t is equal to x of t into x of t minus 2. Okay, x of t into x of t minus 2. As I have told you, the first step 1 is to take the input x1 of t. That means wherever you find x of t, replace it with x1 of t, and its corresponding output I am taking it as y1 of t. That means wherever you find the y of t, substitute with y1 of t. Also it should be scaled, that is a into x1 of t must be replaced with a into y1 of t. That means wherever you find x of t, replace it with a into x1 of t, and wherever you find y of t, replace it with a into y1 of t. That's all. This is the first step. Okay, right. So a into y1 of t is equal to a into x1 of t into x1 of t minus 2. Okay, so a into x1 of t into x1 of t minus 2. So this is the input and it is scaled by a. Okay, so this is the total input, x1 of t into x1 of t plus 2. This total is the input. Multiplication of x of t and x of t minus 2 is the input now. So its corresponding input is x1 of t into x1 of t minus 2. Now it is multiplied by a, as I have told you here. and similarly output is also multiplied by A. Similarly in the step 2, what you have to take is B in the place of x of t, take B into x2 of t. In the place of y of t, write it as B into y2 of t. Okay, so B into y2 of t now becomes B into x2 of t into x2 of t minus 2. So this total is the input. Now it is scaled by B, and corresponding output we are taking like this. So these are the let this be equation number 1, let this be equation number 2. Okay, so what we have is, now individually we have applied the input x1 of t, we have applied, we are getting the output y1 of t. X2 of t we have applied, we are getting the output y2 of t. So we are going to add those outputs, that is a into y1 of t plus b into y2 of t. So that is sum of outputs. This is sum of outputs is equal to, so a into x1 of t into x1 of t minus 2 plus b into x2 of t into x2 of t minus 2. Right, now in the step 3 we have to apply sum of inputs. Okay, sum of inputs we have to apply. That means x of t is going to be replaced by a into x1 of t plus b into x2 of t. So wherever you find x of t, you have to replace it by the sum of inputs. Okay, so its output, when you apply the sum of inputs, we are taking that output as y3 of t. Okay, understand the concept clearly. First of all, you are applying x1 of t as the input. So wherever x of t is there, you have to write x1 of t, and scaled version is there, so you are writing a into. And similarly, you are applying x2 of t separately, you are getting y2 of t. So in the next step, we are adding those two outputs. So that is sum of outputs. Okay, and now in the next step, we are giving the sum of inputs as the input to the system, and we are taking that output as y3 of t. And if y3 of t, which is scaled sum of inputs, which is called as scaled sum of inputs, is equal to a into y1 of t plus b into y2 of t, that is individual outputs. If the sum of the inputs output, or the output of the sum of the inputs is y3 of t, if this is equal to the sum of outputs here, then we can say that system is linear. Okay, so we'll see now y3 of t, that is the output which we are taking here, y of t. In the place of y of t, I am taking y3 of t is equal to, so first is x of t, so x of t is replaced by this a into x1 of t plus b into x2 of t. This multiplied by, now again x of t minus 2, so a into x1 of t minus 2 plus b into x2 of t minus 2. Okay, so in the place of this x of t, and this is x of t minus 2. Okay, so because x of t is equal to this, then x of t minus 2, what will be x of t minus 2? Just replace t by t minus 2, a into x1 of t minus 2 plus b into x2 of t minus 2. So that is what I have written here. So if you observe here, you'll get 4 terms, a into x1 of t into a into x1 of t minus 2 plus a into x1 of t into b into x2 of t minus 2 plus b into x2 of t into a into x1 of t minus 2 plus b into x2 of t into b into x2 of t minus 2. So you'll get 4 terms, but here it is only 2 terms are there. Okay, so y3 of t is not equal to a into y1 of t plus b into y2 of t. So output, the scaled sum of inputs is not equal to the sum of outputs. Therefore system is non-linear. Therefore the given system is non-linear. Okay, so this is how we can find whether the given system is linear or not. Okay. So next question is y of t is equal to 8 into x of t plus 6. Okay, and you are asked to find whether the given system is linear or not. Linear or not. So such type of systems you can say it is non-linear. Any addition of constants, any addition, always remember this, any addition of constants is due to initial conditions, is due to initial conditions. Any addition of constants is due to initial conditions, and initial conditions always makes the system non-linear. Initial conditions always makes the system non-linear. Please remember these 2 points, very very important. So if there are constants in your given equation, that is given question, then we can say that it is non-linear because that constants are due to initial conditions, and initial conditions make the system non-linear. Okay, so that is the concept here. Suppose you have another example, y of t is equal to e power x of t. E power x of t. So whether it is linear or not. The question asked is same, linear or not. So what is the answer? Anybody? Solve it. A into y1 of, pause the video here, solve it on your own and then come for again solution. Pause the video now. Right, see the solution. So a into y1 of t. So a into y1 of t is e power a into x1 of t. Wherever x of t is there, you have to replace with a into x1 of t. Wherever y of t is there, you have to replace with a into y1 of t. Next, b into y2 of t is e power b into x2 of t. So we are adding these two, weighted sum of outputs. We'll call that as weighted sum of outputs. Weighted sum of outputs is a into y1 of t plus b into y2 of t is equal to e power a into x1 of t plus e power b into x2 of t. Okay, addition of these two. That is weighted sum of outputs. Now weighted sum of inputs. Weighted sum of inputs. This is another method to say superposition principle. If weighted sum of outputs is equal to weighted sum of inputs, then we can say that it is linear system. Weighted sum of inputs, that means x of t, weighted sum of inputs, name only specifies x of t is replaced by a into x1 of t plus b into x2 of t, and its corresponding output we are taking it as y3 of t. And if this y3 of t is equal to these, the some weighted sum of outputs, then we can say that it is linear system. Okay, now see, y3 of t is equal to, so this y of t, I am taking it as y3 of t is equal to e power, in the place of x of t we have to substitute it with this one, a into x1 of t plus b into x2 of t. So this is of the form a power m plus n, a power m plus n form. So a power m into a power n we can write it as, so e into a into x1 of t into e into e power b into x2 of t, e power a into x1 of t into e power b into x2 of t. So this is y3 of t. So clearly y3 of t is not equal to, because addition operation is there in the middle and here it is multiplication operation. So y3 of t is not equal to a into y1 of t plus b into y2 of t. That is, weighted sum of inputs is not equal to, so is not equal to weighted sum of outputs. Therefore system is non-linear. Therefore the system is non-linear. Okay, so this is how we can solve. Suppose if you are given with a system like this, y of n is equal to some x star of n, where x star of n is complex conjugate. Okay, is complex conjugate, and you are asked to find whether the given system is linear or not. Okay, so linear or not, then how can you solve this? So for real coefficients, that is, if a and b are real, then it is going to be linear. But for complex coefficients, homogeneity is not valid. So even if one of either principle of additivity or principle of homogeneity is not valid, the system is not going to be linear. Okay, that means when if C is a complex number, if C is any complex number, then C into y of n is equal to C into x of n whole star. Okay, so this becomes C star into x star of n. Okay, so multiplication here is with respect to C, but multiplication here is with respect to C star, which is complex conjugate of C. Okay, if C is any complex number, then C star is its complex conjugate. Therefore, homogeneity principle is not valid in this case. Okay, so that is why you are not going to be linear. Sorry, homogeneity principle is not valid. Therefore, it is a non-linear system. Okay, so this is how we can solve. Suppose y of n is equal to modulus of x of n is the system given for you. Then in this case also the system is non-linear. Because for negative coefficients, homogeneity is invalid. That means if you multiply it with -1, if the multiply output by -1 or input by -1, output should also be multiplied by -1. So if my negative coefficient I am taking, so -1 into y of n I am taking, it will be modulus of -1 into x of n. So modulus makes this -1 positive, so it will be x of n. That means input is multiplied by positive number and output is multiplied by a negative number. Therefore, homogeneity principle is again invalid. So it is a non-linear system. Okay, so this is how we can solve any given system, and we can say whether it is a linear system or not. Okay.